All right, everybody, let's kick it off. Welcome in, everyone. We are AI and Machine Learning Club. My name is Max. I'm the club's president. Today we have a project pitch day, pretty exciting day, because we have 7 students pitching their projects, and we have 4 industry-led projects that we're going to announce at the end of the session. This event is, well, here in person, obviously, so thank you for making it on such a rainy day, but it's also streamed on YouTube, so in case you have friends who wanted to join but couldn't, then you can share the link with them. Okay, so let's start. So, AI and Machine Learning Club, here we are doing our project pitches. So, this is our plan for today. This event is scheduled to last for 2 hours. The first 20 minutes we are going to do introduction and projects info. Surprise guest speaker unfortunately got stuck in traffic. Arjun, he is co-founder of one of the AI companies driving to us from San Francisco, and he will be joining us around 3:30 p.m. today. So we will start doing our project pitches, and as soon as he joins us, we will switch to the guest speaker, and then we'll go back to project pitches. We will do student project pitches first, and then go to the industry-led projects. How does that sound? All right. So for people who haven't seen this slide yet, who we are, a community of individuals passionate about AI and machine learning. We have a website, ai&mlclubsjsu.com. You can look it up, it's going to show up. What do we do? This semester we focus on bridging the gap between the students in the industry, because as you all know, you take the classes, you're being a good student, but then you look for an internship and it feels like you haven't been such a good student after all. So we try to fix that. Crash course, what do? We meet, we run the workshops, we run the projects. This is what this meeting is about. We also have collaborations with other clubs and industry speakers. Our upcoming events, this Friday, we have at 12 p.m. Vibe Coding a Personal Website workshop using Python. Very fun topic. In an hour and a half, we're going to get our own personal website up and running. So if that interests you or you want to learn how to vibe code, please come join us. Friday, BBC 103 at 12 p.m. on the Discord. There is an announcement. And then we're going to have the second round of project pitches, because this time does not work for everyone. So that's going to be next Monday, February 16, 1 to 3 p.m. at Student Union Room 2. This announcement will come in shortly. And I wanted to show you our team again and say that we're still hiring for branding and finance. And let's give a round of applause to our team who made this event possible. All right. Our summary from last semester, again, for people who didn't see this, who did not attend the info session, we had 12 student-led projects, total 76 students were participating. We hosted industry speakers from Apple, Google, Microsoft, and we collaborated with various student organizations. We also had 14 student-led workshops, 2 panels, one was internship panel and another one was for Google event. And the total attendance was 1,320 attendees over 28 meetings. And our team was 27 officers. So Discord, if you're not on Discord, all the information is there. That's the best source of information. We also have the website, but Discord announcements channel is where we post everything that's happening. And our guest speaker, unfortunately, as I mentioned, not here yet, but Arjun Subedi, co-founder of Astha.AI, currently on the way from San Francisco, will be joining us shortly, around 3:30, 3:45 p.m. And now I will pass it to our Chief Projects Officer, Isabel, to talk about projects in a nutshell. Yeah, let's give Isabel a round of applause.
Hi everyone, thank you for joining us for project pitches spring semester. This is amazing, really happy that we're all doing this today. If you're here, you're probably interested in joining a project, or maybe you're even open to leading a project. So hopefully this event like clears up some questions on how you can like get connected to what we're doing this semester and do some really cool stuff in AI and ML. Cool. Yeah, so this is kind of what Max just said. I'll do the overview and then we'll shift into project pitches soon and then have some networking and then some more project pitches at the end. Yeah, cool. Okay. So in this club, we have about 150 active members, and everyone who is in the club is probably also passionate and excited about AI and ML, and we do a lot of workshops and socials. So yeah, it's a great club to be in, and I'm glad that we do these projects here. This is our projects team. This might be kind of small, but there's about 9 of us, I think, in the projects team, and we support all of the projects happening this semester. You can reach out to the AI officers or ML officers or myself as well if you have any questions like during the process, like if you don't know how to pitch a project, if you don't know how to join a project. We're all like pretty social, so you can message any of us. So AI and ML club projects, the parts about it that like make it a club project is that the end goal for the project incorporates AI. So it might use agents, or it might look at language models or transformer models, or it's an ML project, so it has like a classifier or some machine learning model. The projects have a lead. They are 2 members or more, so it can be a pretty small project. And then you also work with a project officer, and they're there throughout the semester to make sure that you're supported with club credits, you're planning things and able to get onto our presentation dates, and that things are kind of going well throughout the semester. The other things that are a part of being in the semester club projects is you create a repository. It can be like mostly documentation if you don't want to host code on our club repositories, but it's great if you do because it shares a lot of knowledge with other students. And also they have deep dive presentations and our final presentation. And this is how you kind of share with everyone what you've learned over the semester. And I think some of us have been to these. They're really, really informative and cool. This is the sign up for, once we have more projects in the spreadsheet, you can use this spreadsheet to sign up for projects. I think it's a bit empty right now though, so sorry about that. This is our timeline for spring. Right now we're in project pitches, and then it'll be about 12 weeks of project work with mid-semester presentations and final presentations at the end. And we also made this helpful document which has some info about having a project in the club. Okay, this is our new initiative, so it's exciting, but we're also doing industry-led projects. And these are projects where an industry liaison is also partnered with the industry lead, and the industry lead might be working on the project deliverable scope or how the project like shapes over the semester, and they're a bit more informed or for like a real world use case as well. So the companies we'll be working with this semester, there's actually potentially more than this. People have been surprisingly open about this. There's Nuvoton, PABet, and Astha.AI, who will be speaking later. We've also been in talks with SiMa.AI, as well as Tesla. So we've been talking to a lot of potential industry leads and seeing what kind of projects we can make over the semester. This is the sign-up sheet for industry projects. This form is a bit more fleshed out than the other project sign-up spreadsheet. So I think you can use this right now to sign up for projects. And I'll also put these slides in the projects channel so you guys can get the QR codes that way. Okay, that's pretty much everything that I had for today. I feel like I could talk a lot about these because I just love projects, but I think it's 3:17, I think we can start switching it over to some project pitches soon. And see who's up first. I think Vikram might be up first, yeah. There's also another one.
Okay, thank you, Isabel. I have a little bit teaser here since we are waiting for our guest speaker and we have some time to spare. This is the Nuvoton hardware that students who get selected for the projects will be working with. And just a little clarification on what Isabel said is we have SiMa.AI confirmed and more details on them later. But essentially, this thing here is a small microcontroller. It's a tiny computer right here. It has the camera, this thing here, and it actually can run some AI applications. So right now, if it sees the person, it's going to estimate the pose detection. And more on this later. And just a little bit of clarification on the logistics before we start. So we do have 2 sign-up forms, right? And don't let it confuse you. One for industry-led projects, another one is for student-led projects. So we're going to have student-led projects first. If you're interested in joining them, please fill in that form. And also the project leads might have some kind of unique way of contacting them, Discord or whatever. Yeah, but to be a part of the project, you would need to go through the form that was earlier shown on the QR code and will also be available on Discord. All right, without further ado, let's give a round of applause to our first pitcher, Vikram.
Good morning, everyone. And my project pitch will be on the Toastmasters AI scheduler agent. So basically, Toastmasters is losing members year by year. And basically, there's one way this project helps is by members understanding how the current economy affects a member's ability to finance Toastmasters membership. And also it can help members identify how Toastmasters helps members today, such as skills, career mobility, confidence, and also community as well. And what this AI scheduler agent can do is automatically assign meeting goals based on availability and also experience level and also past participation and ensure fair rotation of speaking roles and leadership roles. This, and most importantly, this reduces officer workload and burnout so that officers can help other members increase their club mobility and also other club activities as well. Basically, one of the main motivations is that one of the consistent challenges for Toastmasters clubs is scheduling, assigning roles, handling availability, sending reminders, managing last-minute changes, and also making sure everyone gets fair speaking opportunities. Club officers often spend hours chasing members for availability, reassigning roles if someone cancels, and also sending reminder updates and also maintaining fairness and consistency over time. And basically, these administrative tasks take energy away of officers maintaining member growth and also having quality and engaging meetings. So this is a high-level project plan. Basically, the AI scheduler agent, first we can define the problem, then define the AI needs, and most importantly, deploy the AI agent to Toastmasters meeting. And actually as one of the area directors of District 101 in Toastmasters, which is the district of the South Bay area, I can provide a real live club that can that we can launch this AI agent in and test this AI agent in that club itself. And basically, some of the project evaluation metrics, reduction in manual effort, correct role assignments, reliability, user experience, adoption and usage, and also value of the club leadership. Some of the desired member experience, if you have any beginner to medium experience in multi-agent workflows such as LangChain, Python, OpenAI, web development, or even data management, then you're welcome to sign up for this project. A member should also have experience in Git as well as Python and OpenAI and also JavaScript. And some of the roles needed for this project is like a general researcher role, AI agents role, and maybe some model training roles as well. And if you have any questions, you always contact me through my email or my Discord is Brave123. And basically the QR code is a form to sign up for my project. Thank you.
Here we go. We have another microphone for questions. So if someone thinks it's very interesting what they're hearing, feel free to come here and line up for questions. Anyone has questions? All right, then. Thank you, Vikram. So my take on this one is it's very valuable experience. I've been actually interviewing with Apple and AMD, and both of them were looking for AI orchestration engineers, people who know how to orchestrate AI agents. So if this is something that you can put on your resume, can put you far aside from people who don't have relevant experience. All right, so that was the first project pitch, and the next one we have Rohan. Rohan, are you here and ready to pitch? Okay, then please come out here. But without further ado, let's give a round of applause to Rohan.
So the Pediatric Cancer Early Detection System. Wait, how do you? Oh. So why childhood cancer? The problem is desperate. 4,000 children die every year from diagnosis delays. Not because the cancer is untreatable, but because it was caught too late. Systems appeared months later. The patterns were there, but the system failed to recognize them. Oh, sorry, yeah. So what we're building, it's an ethical collision in the loop decision support system focused on early warning signs of acute lymphoblastic leukemia. It will be built using retrospective, de-identified clinical data, CBC lab results, system history, visit history. All right, how will we build this project? It's gonna be a 3-month focused build with a 5-person interdisciplinary team. We're gonna have on board a pediatric oncology advisor guiding development. The basic process is identifying validated early clinical signals, engineering temporal features, which is patterns over time, training a high recall interpretable model using logistic regression or SGBoost, and using explainability tools, specifically SHAP, for transparency. The project is designed to be ethical, so there will have a clinician in the loop at every stage, no autonomous diagnosis, no automated medical decisions, decision support only, full transparency, explainability built in, audit trails, and uncertainty disclosures. So this is what the final lightweight web demo is going to look like. It's going to include patient summary, feature-based explanations, risk tiers, suggested next steps, accountability logs, and clear uncertainty indicators. So the roles we need for the project is currently an ML engineer, a front-end engineer, back-end engineer, a business vision director, and we are currently working with a clinical oncologist from Stanford on bi-weekly basis starting February 23rd. So this project is not about This is not about replacing clinicians. It is about giving them better tools, better pattern recognition, earlier detection, better outcomes, fewer late diagnoses, and fewer families hearing, "We wish we caught it sooner." Thank you.
Thank you, Rohan. This sounds like a very impactful problem that would give you the full scope of understanding of machine learning cycle, from collecting the data to training the model to testing the model and then to explaining why the model gives you a specific answer. Unlike some deep learning models like ChatGPT, where we don't really know how it reasons and operates. Things like this, they need to be explainable because we always must provide the reason when we do some kind of medical diagnosis or, for example, credit risk assessments. Okay, well, that was 2. And we are gonna be moving on to the next one. The next one we have is Xingran. Are you ready to go? Let me pull up your slides. So far we have a pretty good mix. We have agentic AI, we have traditional machine learning, and let's see what this one brings. Let's give a round of applause to Jan. Not sure which one.
Testing. Hi guys. So this is my project that I've already started building out by myself, and it's basically a RAG model in Obsidian. So the reason why I chose Obsidian is that it is, if you ever used anything for note-taking that's on the computer, I think Obsidian is a great platform for that. It's closed source, but everything that you write in your notes stays local. So you have all the files. It's not like Google Drive where it takes your data, right? And one of the problems I have is basically whenever I use an LLM, I hate the idea that the moment I don't have internet, I just can't access and do anything with AI. And I also don't like the fact that it basically takes everything I say to it. Like, if I say something embarrassing, I know a lot of friends that like they journal with ChatGPT, and I'll be honest, you could not kill me to do that. Like, I do not want OpenAI to know everything I'm thinking about. So, again, Obsidian is one of the most popular free note-taking apps, and it has a lot of user bases and has strong support for plugins. So that's why I chose to build it on Obsidian. And what I was hoping to do is that I was hoping to self-host the LLM using Ollama, and then whenever a user writes down their notes, they will be able to generate a response based off their own notes. So that if they ask, for example, what did I learn in like lecture 5 of my calculus class, right? It will directly link the note and generate a response based off of what you already have noted down. And I think that'd be something pretty cool. So this is what I was hoping to do with this project. I'm not expecting to build like some type of industry killer project. Like it's not, if I can get 50 users for this, I'd be pretty damn happy, okay? But I was hoping to have use this as more of a learning project, so I have a little bit more of an understanding of exactly how a RAG pipeline might work. And especially if I'm hosting my own LLM model, I want to know what kind of trade-offs there are in terms of hardware and the latency. It's like if you use like a really large locally hosted multimodal model, it's super, super slow. Like if right now I know that for example, if you use like Google Maps, recently they put like Gemini into Google Maps, and the latency is just horrible. Like it takes like 3-4 seconds for it to do anything anytime I speak to it. So I wanna find out how to speed up that response time by doing by basically building this project out by myself. And eventually, if we can get that MVP working, I want to go to one of the hackathons and maybe demo it. And then also you can flex on your resume a little bit. It's a nice little bonus. And also because I think this is more of an ethical tool that I might actually use myself from day to day. And then so here are some of the key features I was thinking of. The first thing is it has to be a locally hosted model, which means everything that from the user, they first choose to use this application, they should just hit a button, installs whatever model they want, and then they're good to go. They shouldn't rely on Gemini or OpenAI or any other commercial models and basically do a bunch of API finagling. And then I want the user to be able to have some type of control over the context. So whenever they have a bunch of notes listed out, they'll be able to whitelist and blacklist these notes. So for example, if say the model like goes and hallucinates and pulls from a node that you do not want it to associate with, you'll be able to go, this response is wrong, let me blacklist this node, and then it will just no longer access it. So then you'll be have some kind of control over exactly what the response will be. And then source transparency. So whenever we, like, if I ask a human being, right, hey, find me something about this research paper, like, you will quote it. You would go to the research paper and be like, hey, this is the exact quote on which page number, and this is where it's from. And I want the model to be able to do that as well. I recently found out that there is a tool for that from that's open source. So I'm hoping to include that in my project tech stack. And eventually, if we find that the knowledge base for using your own Obsidian notes isn't enough, I was hoping to add a web-based retrieval later on, but that's like a bonus thing. And then finally, the process. So how we're actually gonna build a project. Again, Obsidian, really great plugin ecosystem. I've already been building it out. Has a lot of introductions. So even if you're someone who has no experience, I don't care. Like I feel like with AI ML, a lot of times you just not really anybody like knows exactly what they're doing, and that's okay. You just come in, you learn, you play around with the tools that you feel like you could pick up, and then we try to build something with it. So this is the basic user flow. You would edit your Vault or your Vault notes, and then a Firewatcher would look for the edits, and then when they find an edit, they will parse it, and then they will take that what they think the notes is about and put it into the metadata. And then whenever we query our locally hosted chatbot, it will go into these metadata, fetch the one that thinks is the most relevant, and then generate a response. And the user is unhappy with the response, they can directly edit the context by white or blacklisting notes. And this is the tech stack I'm thinking of. So Obsidian allows for React. So I've been using React. It works pretty well. And then there's this file watching library called Trocadar. So that'll be the one I'm using right now. And for the local LLM, it'll be Ollama, and we can pick out whichever model is the best. And then for embedding, I haven't gone that far yet. This part of the logic I'm pretty confused about. So if anybody has an idea and is interested in contributing, then please let me know. And for storage, I'll be using SQLite. So yeah, if anybody has questions, feel free to shoot me a message on Discord. My Discord is Derpter, and my email, I should probably put that on here, but I didn't put it on here. But it's my full name at SJSU.edu. Yeah. I built out the front end, and I downloaded the lightest weight Gemini model, and basically I can get it to give me a response. But I haven't added any of the logic. I haven't done any of the embeddings or anything. So that part is obviously like the bulk of the actual thing. But I did get started. Yeah. Yeah. Sorry. Yeah, mainly most of the logic is in the back end. And the front end, I'll be honest, it's like there's not a lot to be done because I already built out like the most basic parts at least. And I don't know why I'm not talking about the mic, but yeah, the front end is already built out. It just shows up the message from whatever model that I choose to. So basically how it works is that you have a model that you will host, and you have like this local host that kind of takes up like a, you know, your local host port, right? And then your front end literally is just listening to that port and then just getting some kind of response back, and then just shows it up. That's all it does. Yeah.
I have to compliment a couple things. First of all, the presentation itself, the slides are very minimalistic, not overloaded, and the presentation itself is also pretty good. In terms of applicability and relevance, I think this is a very relevant problem statement. A lot of companies have LLMs and they have data, and they're trying to figure out, do they just throw the data at the LLM? No, it doesn't work. It hallucinates, it gives them inaccurate results, and ends up driving the costs even higher because now they run LLMs and they need to double check it. So a couple of things that were mentioned here are context engineering when you decide what to show your LLMs, referencing, LLM running locally, which is also a big trend because we want privacy. As Jan mentioned, we don't want to just send all our secrets to ChatGPT. Well, hopefully we don't, but I know some people do. So anyway, that was our third pitch, and also a little bit of announcement that now on our Discord channel, we did get the link up. So let me just show you quickly how to do this. If you go to our Discord, AI and ML Club Discord, on the club announcements channel right now we have this link. And if you click on this link, here we're gonna have the projects. So if you're interested in projects and you wanna sign up, the column name right here is signups. So you would need to put your name and Discord ID here. And again, the link is available on Discord, club announcements channel. So if project sounded interesting to you, please go there and sign up for it. Jonathan, would you like to come up here? Let me get your slides. EMG. Wow, isn't that something that Facebook or someone does with their smart glasses, right? That type of thing? Nice. It's called Got Inspired. Didn't steal it, got inspired. All right, let's give a round of applause to Jonathan.
Hi, everyone. Yeah, I'm Jonathan Makoko, and I'm currently doing my master's here at SJSU. And yeah, I'm just here to present my project for synthetic EMGs. Before I get started, I guess, can I get a show of hands of who knows what like EMGs are? Okay, cool. So for those of you who don't know, I'm just going to simply explain that EMGs are kind of like a muscle to computer translator. So essentially what you have are these electrodes, as you can kind of see in the image to the right. And what these do is they can record signals. So these like small electrical signals that when you move your arm, they'll generate these signals. And basically what you can do is this allows you to basically convert your movements into kind of this data that can be used for prosthetics. And so getting into the problem description, there's an issue with EMG systems just because they're sensitive. They can suffer from signal degradation. So what happens is if say like you're sweating, you can suffer from electrode shift and channel dropouts. And what that'll do is that'll basically make it so you won't be able to work with your prosthetic limb. And so for companies like Open Bionics, they actually have these non-invasive prosthetic limbs that allow you to use it with these electrodes. But there's an issue at hand because when you sweat, for instance, they had a user who was working in attics and he had a prosthetic arm. And after a while working in the attics, it gets pretty hot. And so he started to sweat and he lost use of the prosthetic. So the goal is to test and validate the synthetic generation of EMG generation, signal reconstruction using generative models, and see if we can improve robustness under signal loss. So say there's a signal dropout, can we use a generative model to generate the signal so that way you're able to still use the prosthetic arm? Moving on, just as simply the data set I plan on using, it's the Nina Pro DB2. This is widely used for research in this kind of area. The reason it's so good is because it has 40 subjects, and each of the subjects are doing multiple hand gestures. And so what this allows is for us to have a wide variety of gestures to work with that allows the generative model to learn from. This is good because it's also free and available for anyone to use, which was nice. And so the way that they kind of got their data is they had this really fancy glove that was able to basically detect all the movements, as you can see in the top image. And just to kind of get an idea of what we would be generating, I printed out some of the data from the data set. So this is just from one of the channels. And as you can see, this is a time series data set. So the horizontal, it represents a specific time and a specific, at that time, an electrical pulse that's being sent. And so this kind of brings me into like the next slide, which is the methodology. So because this is a time series data set, there would need to do some pre-processing, such as a segment EMG recording using a sliding window technique. Basically, we're trying to retain windows with the dominant gesture label, so open or closed fist, based on the specific window and time of what the sample is doing. And then once we are able to pre-process the data, we need to also normalize the EMG signals per channel. And this is so it makes it easier for the generative models to learn. And then the current generative model that I'm planning on using or developing is a WGAN GP model. It's going to be a conditional model using the gesture labels with one-hot encoding. The reason is because in past experiences that I've had for generating synthetic data, WGAN GP is proven to be very useful. So the project metrics, so RMSE, so how closely synthetic EMG matches the real EMG in amplitude, and then gesture classification, so assessing whether synthetic EMG can effectively train models for real EMG-based tasks, and obviously testing the robustness, so how well the synthetic data is able to help with, say, the loss of a signal, and able to keep the signal going. This is just some related work. There's an article, as I mentioned earlier, about how Open Bionics had a user having issues with their prosthetic just because of sweat. And these are also just some other related works for in the kind of medical field for generating synthetic data, because this not only helps with like the issue of signal dropout, but also the fact that it's really hard to get medical data due to privacy issues. So being able to generate your own kind of data set would be very helpful and useful for research purposes. And then just some member experience is like PyTorch, Python, and some ML class experience in Git. But in all honesty, it's not really needed as long as you're just kind of willing to learn along the way. And yeah, that's my Discord. So if you're interested in the project, yeah, just let me know. Yeah. So what happened is in this one they have 12 channels. So they have like 1 through 9 is attached to the forearm, and then the other, 3 are attached, or 4 are attached to like the hand. And so they have these gloves that the users would wear. And so this basically, because they're having so many channels, this allows for like a wide variety of features that are able to include in the model, which is really nice, and it's like used in quite a bit of research papers. Oh, and yeah, this is more of a research project as well. So if the outcome is good, we could hopefully publish a paper on the results.
Okay. This one is another machine learning end-to-end project, which is again good on hard machine learning skills, how to get the data, how to put it in the model, how to make sure the model is not overfitting. So this one is pretty good hands-on experience with that. And also I wanted to mention that it's in a biotech area, and the biotech is a very prominent field, growing very quickly, especially with AI and machine learning. And ships and satellite imagery. I know a person who actually worked on very similar problem statement. I'm not sure what's up with this. Here we go. All right, let's give a round of applause to Nir.
Hello, everyone. To be very honest, I didn't make this presentation with so many people in mind, but here we are. Um, Welcome to Ships and Satellite Imagery. Basically, it's a bunch of, to be very honest, Kaggle datasets that are just compiled together to create this project. Okay, but why do this to begin with? First of all, have you guys heard of Somalian pirates? Yeah, that's number one. Number two is the Chinese military vessel hitting the Filipino vessel, if you guys remember that. And effectively just random border tussles and other stuff. More importantly is if a ship goes missing, what are its coordinates, where was it last located? And the main problem with normal traditional search and rescue operations is it's expensive, it requires a lot of human labor, and it's just not feasible if the ship went at Point Nemo, which is the deepest point of the earth, the most isolated one. It's not possible to just throw an airplane and find the people, right? So the solution is satellites. Do not question the image. Basically just look at some geostationary satellites going around and you'll be able to find the ship or any weird things that could hint to something going wrong, right? Okay, so let's go into the dataset. This is the actual project. These are a bunch of pictures that I collected from datasets all over. On the top, you'll see ships that are either partly in view or are just islands and random stuff. Bottom are full-on cargo ships. Looks like there's only cargo ships here. And the other one shows speed, velocity, and direction of ships. So the motivation behind this is to basically just classify what is a ship, what type of ship it is. And while this might sound like, oh, just throw a random convolution in it and you'll be done now, the dataset is extremely messy. Some of them are in PNG format, some of them are in XML and other stuff, so we gotta change that. Some have training data, some don't. Some are really blurred and some are really clear. So the main idea is to use these images, change and do some EDA on this, and dive into classifying the ships. And yeah, that ship looks a little weird. Oh well. If we have time, if the project permits, also to classify what kind of ship it is. Is it a cruise ship, a military vessel? Is it a dinghy? Or, Somalian pirates? So some ideas we can implement are, obviously we'll start with a convolution first, because that's the go-to. But implementing a transformer encoder, a CBAM, or a just visual transformer to begin with. The main motive behind using such weird and complicated tools is because of looking at the wake it produces, because a dinghy produces a different wake compared to a cargo ship that's going at 30 knots. How big the wake is it different from a normal ocean wave and other stuff? And maybe add other cool stuff to it if someone has ideas. Okay, so who can join? Anyone who wants to work, really. Knows Python and Git, knows what deep learning architectures are, have a basic idea of neural networks. And yeah, this is not like an industry project. This is mainly for learning experience. We will make the project from the ground up. So anyone's free to join if they're really interested. And yeah, that's about it. That's my Discord. If you guys can see it at the back, that's my Discord handle. And here's a QR form that is for interest, though I don't think you'll need it. Right, that's it.
All right. There is a question. Sure. Yeah, one question. We're running short on time, but let's get one question, please. But I was going to actually steer it into this direction that this is for people who have potential maybe potentially interested in working in military applications, because imagine you're United States military, of course you want to know where all the ships are. Who wouldn't? And they pay very good money. Yeah, I think that's a great computer vision application, again, to learn end-to-end pipeline of machine learning, to learn how to work with the data, how to slice the data, make sure that your model doesn't think that islands are ships, because I would imagine that's a big problem. But anyway, we are going to move on to our next presenter, and I think then we're gonna switch gears to our guest speaker. Okay, so Akshat, would you like to come out here? All right, let's give a round of applause to Akshat.
Thank you. Hi guys, my name is Akshat. I'm a first year studying computer science here. So just by a show of hands, if I could quickly get how many people have heard of MoltBot or CloudBot recently? Yeah, a lot of people, right? So this is taken over X and taken over Reddit, and people are posting about its potential applications. One thing people are not talking about enough is how difficult this setup actually is for people who are non-technical. So people in this room might understand a lot of, keywords like API or environment, but people who are non-technical usually have a hard time figuring this out. So obviously MoltBot, which used to be called CloudBot, is very popular. 1.6 million agents are on MoltBot currently, 182,000-ish GitHub stars. So again, the problem is the setup for the user who are non-technical is extremely complicated. One, you have to figure out the hardware, whether if you have a laptop that's just, that you're not using, or go ahead and set up a VPS, which again is a difficult thing to do if you haven't done that before. Set up your environment, which is install Docker, Python, Git, whatever it may be. Then clone MoltBot from GitHub. And doing all of this in Unix or Linux can be pretty difficult. Then set up your API keys, and also figure out guardrails for the agent so that it doesn't go ahead and delete your system files. And then maintenance as well, as the open source library advances and becomes bigger, constantly having to update it or maybe customizing it is a pain point for a lot of people. Even technical, it might be repetitive doing it again and again. So the solution is MoltBot for all. And what we're trying to do is making the process of onboarding extremely simple. Just the user comes, scans, connects to whatever API they have. Could be Anthropic, could be OpenAI, could be Gemini. And the bot is immediately live. We handle a lot of hosting the API keys and sandboxing in the backend. One trade-off there is customization. But based on the research I've been doing, I understand that people who are not technical just want to see something active within the first 10, 15 minutes. Like when they can see an agent do something, that's more valuable to them than pure customization. So yeah, we'll handle all the agent guardrails and boundaries. And then users, in terms of how we're planning on maybe monetizing this, is you can either bring your own API key if the users was semi-technical, or just have a simple subscription model. So then we can cover the API charges. Again, so we're building the action layer of AI. The MoltBot is core right now. The MoltBot is the open source library that will be used forking on top of. But down the line, I see a lot of other potentials being security and firewall. I think cybersecurity in this space could be a very big application. As these agents grow, the number of agents grow, there's a lot of cybersecurity potential vulnerabilities that might be present. And having agents that look for them and have good guardrails around them is a potential tangent that I think we could grow into. Having swarm of multi-agents that, for let's say a barber shop or a business that does plumbing, having specific agents that run their business tasks for them and selling to these potential customers is the direction I was thinking of taking this. And once we solve the access problem, which is step one, I plan on making an ecosystem around this. And so we'll be building security, the economy, and the workforce of the future. So this was one analogy that I thought was very interesting. Cursor was just built off of VS Code, which was open source. And it was popular in the developer community, but never really the LLMs in, using LLMs to generate code wasn't really actually made popular until Lovable came out, which then became the fastest growing company to go from 1 to 100 million ARR, faster than OpenAI, faster than Shopify. And I see that market emerging once again, but it hasn't been done yet, where MoltBot is an open source tool, which is sort of stuck in this bubble of developers and people who are always on X, but doesn't really reach the average consumer who may be using Instagram or YouTube Reels or Shorts, whatever. So I want to do something similar to that using MoltBot, and we're calling it MoltBot for all. So yeah, the opportunity and vision is pretty clear. This is very new technology, and there's a lot of hype around it, and I think we can, optimize for that, and the time is right now. So if you're interested, the positions that I'm looking for are an agent architect, so building the router that decides which model should be pinged, whether an Opus 4.6 might be better or a cheaper model which infers lesser cost. Platform infrastructure engineer, so again, building the sandbox so that it's an isolated environment where the agent can work. And third being machine learning engineer, which again reduces dependencies on LLMs, APIs. One thing I was thinking of doing is similar to how Cursor, after a couple years of being in use, came out with their own model, Composer, which they trained on their own data. I could see a similar application here where if we have enough data over time, we can build our own model based on the training data that we've used from the users. Yeah, I think that's it. Yeah, thank you.
Thank you. Right, so this is also a very cool pitch, some very recent technology. I'm not even fully familiar with this, to be honest. Actually, I have no idea what this is. So that's pretty cool opportunity if you're trying to stay on the edge, and also sounds like something that might lead into a potential startup. And that's actually something that happened in this club before. Some guys, they put together the project, started as a project, and then ended up doing a startup. So we just discussed a little bit arrangements with our guest speaker, Arjun, and we're gonna finish student pitches first. So Joel, Lucas, are you here, ready to pitch? Yeah, right here. Let me get your slides. Yeah, this guy has a lot of support. It's always anxious when you graduate, for people who already graduated, and you're gonna wonder how many people are gonna clap. But anyway, let me run this as a slideshow. And it does this weird thing again. Here we go. Okay, let's give a round of applause to Joel Lucas.
Thank you. Alrighty. Hello, guys. So this is just an idea that I came up with a couple months ago that I thought would be a cool project to pitch over here. It's called NeuroDiffusion, or diffusion. So the idea that I came up with is that imagination is such a powerful tool. For example, everyone in this room can imagine anything they want. Now, this is something that has basically built the world around us. Everything that you see has come from somebody's imagination. So what can we do to kind of harness this? So right now, the way imagination is kind of depicted amongst each other is through words, trying to visualize words, for example, giving out some pitches or something like that. This can be somewhat effective, but oftentimes you kind of can't get the quite picture that you want to present to others, right? So what can we do to kind of bridge this gap between words and what we are truly visualizing in our brain? So the idea is to find a way that we can directly communicate with our brain and just generate these images to everyone else. So we are just trying to basically take our brainwaves and generate images in the way that we ourselves see it. So this is the idea that I came up with. So now this is completely a little bit out of my scope in terms of neuroscience. I'm not too familiar with this, but it is something that I am willing to learn. So right now, this is the idea of how we're going to complete this. We're going to do some research. I've done kind of a brief dig into what this area is currently looking like. Right now, they've done some fMRIs, EEGs, and essentially they have some type of like perceptron to diffusion model type of setup they have. Once we have this going down, once we research everything, we're up to date with everything with the current knowledge, the idea would be to reproduce this, try to recreate what is the current standard. Then eventually I want to get into the innovation. Now this is something that will probably come down later in the line. I don't know how fast we'll be going on this, but the idea is we can maybe go into where it's just free imagination rather than just seeing what you're seeing and reproducing it on the computer screen. We are now just imagining certain, I don't know, a green apple on a stick, for example, will be generated by a diffusion model. And eventually we can maybe even take this further into unknown areas, for example, maybe depicting what your dreams are at some point. So the idea here is, like I mentioned before, we're going to just be utilizing some public data sets, such as fMRIs and EEG data sets. And then we're basically just going to train and validate the models, try to recreate what people have already done. Aside from this, there's also basically the clip that you see over here is contrastive language image pre-training. And this is basically just stuff to do with the brain waves. So this is stuff that we'll, as a team, will finally kind of look into and get a better understanding of. And then finally just reconstructing this, but in a little bit higher quality compared to the current standards. Now for what I'm looking for, it's not too much of a project that many people might be passionate about, but if you find yourself kind of curious in how we can maybe bridge this gap between mind and visualization, I would love to work with you. This is something from ground up, so I'm not looking for too much experience. I don't have much experience in this field in terms of neuroscience, but I am going to basically learn my way. So if you're open to learning new stuff, even if you have no experience in AI, ML, I'm open to working with you. And basically what you're going to gain from this is just a bit more understanding in AI and I guess a little bit more in neuroscience. And that's it. So if you want to join, here's the Discord. Yeah, thank you.
That's a really cool pitch. I think it definitely wins the most novel idea. Again, a really cool, relevant field. Brain-computer interfaces are growing. Neuralink, the invasive one. For this one, it's probably going to be some kind of, well, to start from just data set, but then depending on how much this thing costs, we can maybe even sponsor the thing that reads your brain signals. I know that Berkeley does this, but I also know that they have much more money than we do. So we'll see about that, but really cool project. And UberX. That reminds me of one moderately popular company. You guys heard about Uber? Are you worried they might sue you for this name? They actually have UberX as an option. But anyway, let's give a round of applause to our next pitchers.
Hey guys, this is our project pitch. It's for Urbex.AI, which is essentially a AI-powered urban exploration location discovery. I'm Soham, and this is Asim. So just for a raise of hands, do you guys know what urban exploration is? Kind of exploring abandoned buildings and stuff like that? Okay, that's great. So I'll just give you a little bit of brief overview. So Urbex is essentially discovery and documentation of abandoned, forgotten, and off-limit man-made structures, and it's about preserving the history before it disappears. As for its cultural significance, it's for the community that these spaces are time capsules, and the cultural values that respect for the location, which is take only photos and leave only footprints. As for the graffiti there, it's not more of trash, it's considered as art, as it kind of has a raw form of artistic expression, and it adds layer of modern narratives to like the decades of art that's been there in locations. For our problem description is that users have had a hard time finding these certain locations, and how it works at a higher level is that we'd have some sort of AI kind of parse through data to satisfy the user's input, and we'll have more on that later. And as for our goal, it's that to make it easier to find these locations by prompting the AI with a certain target location and where it will find more locations in that certain area. So for our motivation as well is that we've done urban exploration before and we know people that do this as well. And what's been a pain point is finding those locations, like I said, and how to like get access to the places to go to. And that's kind of what we're focusing on here. For our current data set, we have a kind of a dummy data set with about 6 dummy locations. And we're doing this to make sure that the website kind of has a functionality before we add the AI aspect to it. So kind of a brief overview of our high-level plan. It's a cyclical AI-driven architecture which transforms the user's queries into more of a safe, personalized urban exploration route. So we'd kind of have the website says app. The user would input in something, and then the intent classifier says NLP. It would parse for the certain word they put in, like for example, abandoned factory, and that go to the location filter engine, which would kind of match the intent to the data, like what location you're looking for, and etc. And with that, it would base a rank by the risk in the profile about the location and would shoot it back to the user with the area they give and how you can get to that location. So our current UI is kind of like a product snapshot we made of a certain website. It's called Urbex.AI. You find abandoned spots across California for now, but it's definitely scalable. And we have like some sort of search filters by city, by the type of the building, and by how easy it is to get into the building. And for our current state, we're showing our 6 dummy locations, which pending the database connection to actually get to like all the other data we're gonna mine to.
So as of right now, Urbex.AI uses basic sources like Google Maps and also requires manual verification, which kind of reduces both speed and accuracy. So in the future, we plan to integrate machine learning to automatically like parse through multiple sources all at once. Like this includes sources like Reddit that we can use for maybe community insights, or even YouTube for like visual references to these locations. So the point is that we can bring all these sources together to gather more reliable information. And in the end, this would make our platform faster, smarter, and most importantly, more helpful for the user. So Urbex.AI produces 4 outputs that the user can use while they're exploring these locations. First is clear access information, so the user knows how to enter safely. And second is difficulty, which is where our program matches each location with the user's experience level. And third is precise GPS coordinates, so the user knows exactly where to go and they don't have any confusion. And finally, fourth is popularity metrics, which tells the user how busy a certain location is. So they can either pick between a well-known spot or, if they want, even a secluded one. And in order to measure success, we tried to follow like a 3-step plan. And the first step in that is to make a website that uses real location recommendations. So, and then right after that, we wanted to do some user testing with either some friends or family. And this would give us some practical feedback about how we could like go further with this in the future, maybe some next steps or like a roadmap. And finally, we also wanted to implement a thumbs up and thumbs down kind of a system with our AI, which would help it learn and improve as we keep working on this project. And we plan on using like multi-agent workflows with either LangChain or Python, still deciding. And also for the web development, we've narrowed it down to either Next.js or TypeScript. And as far as data collection goes, we're planning on mainly using Python scripts. And then for model training, it's either going to be TensorFlow or PyTorch. And for the cloud architecture, it's either we've only researched Google Cloud. So yeah, we're open to suggestions for the future, but yeah, we've only done Google Cloud so far. And in order to bring Urbex.AI to life, we've narrowed it down to 5 important roles that we need to fill. First is the general role, which kind of guides product vision and coordination. Second is the AI agent role, which basically builds a system that searches for data. Third is the model training role, which makes the data sets themselves and improves our accuracy. And third is our full stack and cloud role, which develops and deploys our final version itself. And finally, the data collection role, which makes sure that we have all information up to date, high quality. And yeah, thank you guys for listening, and hopefully with your help, we can bring this to life. And we have our Discords up if you want to join.
All right. That sounded like a well put together startup pitch. That's going to mark our last student-led project pitch for today. And just to kind of summarize and move on, I think that if you're here and you're considering joining one of these projects, or you want to pitch next Monday because you saw how it looks and you're like, oh, I also have a cool idea. So couple things. If you want to join as the project member, that's a really good idea. Why? Because here in the classrooms, you work on the projects with professors, but these are not the actual things that you will be building as you work as an engineer. As an engineer, you will be working with the people who are pitching the projects today, this kind of people, once you get in the industry. So that's your kind of an early ticket to see how it goes and maybe to enter that phase. And
So
with that said, I think we're going to transition to our industry part. So just to give you a brief idea of how it look, we're going to have Arjun, co-founder of Astha.AI, pitching us something for about 15 minutes. I'm not necessarily sure what the content is, but it's exciting to have him. And after this, we're going to have 4 industry-led projects announced. So 15 minutes for Arjun, 30 minutes for that. After which, we're all going to go to Starbucks, and project leads can network with project members or Arjun and me, whoever you'd like. So with that said, let's welcome Arjun, the co-founder of Astha.AI, on the stage. Let's give him a round of applause. Pulling. Well, you know, the students are up to date on the slides.
Okay, perfect. Thank you. Okay, you guys can hear me, right? Okay, thank you so much. I could not make in time, but I arrived here. So basically, I'm the co-founder. I lead product at Astha, and also I lead Safe MCP. It's a agent security governance framework, and I have a few stories I want to kind of share all of you. And I think it would be a very interesting startup story too, I think, as you're learning. So the Astha, when we started like 8 months ago, we were thinking agents gonna happen. There will be a lot of agents in the world. And by the way, I also lead one of the big deep tech community in the Valley. We connect founders and VCs and all those folks together. So I like to say myself, I connect darts and build bits. So both, like I like to do both of those. So last year I had this thesis that when, you know, agentic, like people were building with LangChain, a lot of POCs, you know, everybody were building agents in hackathons and all those. One thing I really saw in common pattern is the industry is like exploding. But the thing, the pattern there was the security. That's the common denominator, that if the security gap is there, although the POC will explode, a lot of people will experiment, but to have enterprise adoption, that's where it will be the blocker. That was my initial thesis, right? And me and 2 of my co-founders, we got together and started like working on that thesis. And we thought, okay, what is the first thing we could build, right? And then we thought, okay, for a simple analogy, when you travel around the world, what's the one thing you really need? Passport, right? That's the common guardrail, like digital guardrail every country would have, and you would use passport, and that is the identity we have, universal identity. So we thought maybe we'll build a universal identity for agent, right? Then in that way, we started agentic zero trust protocol. Actually, it is identity protocol we started. But at the time, A2A came. So we were like, oh, we're fighting our protocol against the Google protocol. So we're like, we did the agent identity. But when we were building agent identity, everybody were doing hackathons, and they didn't care about the identity, because you want to build something that works, not like secure, right? First, it has to work. So we were way too early. Then we were kind of thinking, okay, what is the one thing the industry needs? And we're talking to a lot of CISOs who were making the security decision in big companies, like, hey, what is the one biggest thing you are afraid of this agentic adoption in your companies? Then like the big question was, it might be secure, but I have no way to govern it, right? Like, because what happens is when the data leaks in a big companies, then it will go in Wall Street Journal for a wrong reason, and that's what they don't want, and they might get fired. So it's not the technology problem they were looking trying to solve from agent. They were really afraid of. It's the compliance problem they were afraid of. It's like, I do not have language. So actually, that was 7 months ago. We were like really thinking, and we were talking to those guys and said, hey, well, what do you have the issue? And then we realized that the industry doesn't have a language, right? You have the MITRE, if you guys know security, like you have MITRE attack techniques. Those are where it has like 14 attacks. It kind of documents all the application-related or cloud-related attacks. And when we are kind of zooming in on the agentic ecosystem, when MCP came and agents came, we didn't see any kind of even standard documentation around it. So that's where the safe MCP comes actually. The MCP itself is kind of a funny name. It's actually we do security analysis not for only MCP. We do for agentic ecosystem. So we used MCP because MCP was hype. We're like, let's steal the name, I guess. And now it feels like a liability, I guess. So that's where the safe MCP came. But now it's a part of the safe agentic framework. Guys, please QR that. It will take you to GitHub of the safe MCP. And it's part of Linux Foundation right now. We are under OpenSSF umbrella. And we have a lot of industry like security folks and engineering leaders from multiple company contributing to us. We have like few logos are here, but right now it's exploding. We have like 50, 60 logos, companies, people are coming and contributing on it. So that's where the story started, okay? So now I wanna go a little bit about, this is our community, obviously, we are doing a bunch of things. That's one of my co-founder there, Frederick. He's an industry veteran, has done so many things. So another analogy I'll give you. Sorry, my slides are two color because I kind of tried to merge two slides. I asked Claude to do it, it failed 5 times. So I'm like, hey, okay, I'm gonna do manually. So yeah, sorry about the color. So this is a good analogy I want you to kind of really think about. When you are building agentic system, think about you are building a submarine, right? For a small lake. Then what would happen? A small lake that is I don't know, 30 feet deep. Then at that time, one thing you would think is, okay, it should not maybe crack, right? And then it should have enough oxygen inside. So you go and take a dip, right? You could make that at home. I mean, in backyard, I guess. But think about you are taking that submarine and trying to go deep in Marina Trench, in ocean, in Atlantic or in Pacific. What's gonna happen? If it cracks, you're dead, right? I think we need to think like that when you are taking agents, building agent, and if our end customer, or if you are trying to deploy that agent in enterprise, we need to really think from that angle. So that's where you really need to think about what are the possible attacks it could happen on the agentic system. So that's where the safe MCP really comes. They're really science. We actually help to document all the attacks, possible attacks the agent could have. Right now we have documented around 80 attacks. And how the attacks are documented is like this. You guys all know 404, right? It's a page not found, right? As a computer science student, we all know that. I said a number and you all know. You all know all those codes, right? It actually standardizes the kind of network kind of errors, right? So what we have really done is all this SAFE T1001 tool poisoning attack, we codified. Safe MCP actually codifies all those numbers. So those are the numbers, and we map to the industry. That's ATK or MITRE attack techniques. Those are used by all big companies. We introduced those techniques. So right now we have introduced 80 techniques. So in that way, when you are mapping that submarine, right, you are looking from 80 different ways how it could crack. So in that way, when you are building agent, think about when you build the agentic platform today, right? What you do? First, in Claude, you would go and say, hey, I need a big plan. I need a big architecture, right? And you will have this architecture where it will say you will do all these kind of things, right? Right at that time, you need to think about, hey, give me a plan how this architecture can be attacked. You need to kind of think right on that time. That means like saying, hey, I am building a submarine. Show me how many ways it could crack. That's the same analogy you are doing here. And for that one, safe MCP really helps you to kind of really sign. And then when you are kind of saying, hey, my agentic architecture might crack here, might break here, might be attacked here, you are putting, think about you're putting a LOTF there and writing a number. That's the number you're writing, safety 1001. In that way, you are really saying, in my agentic system, how many ways it could be attacked, you actually mapped it. Now your job is what? Just mitigate those attacks, right? And in that way, when you build your agentic system at the end, it is very robust and very compliant, because all those LO tags you wrote, 1001, is actually mapped to the industry standard, MITRE and others. Because safe MCP, you see the ATK TA001, that's actually, it is mapped to the industry standard. So that's the value safe MCP actually does. And we started that 7 months ago, and now it's it is getting a huge momentum in the industry. So that's the general idea of what is safe MCP is about. So right now, like that, we have 80 plus attack mapped. So who can use this, right? There are multiple personas that can use it. You have security teams, they can really see, hey, what are the different ways the agentic system can be attacked. For the developers that I was talking, when you build the architecture in cloud, your agentic architecture, you right away ask, hey, what are the possible ways this agentic architecture can be attacked? You could create that, actually, your attack mapping right away. And for compliance officer, it's amazing, because in that way, guys like CISO would have a, hey, you gave me all the ways my agent can be attacked. Okay, now I can make them compliant. So they can, they have a way to govern. And red teams, obviously, red teams are the people who actually do a pen testing, right? And they will try to figure, these are the way they can see, hey, let me try to break this agentic system in 80 different ways. So this gives those kind of path for them. So these are the 4 personas, like it is really helping. And I want to go to the next, like safe agentic use case analysis. When we were building these techniques, right? When we were building those, the yellow, you know, like on submarine, as I was talking about those yellow tags, trying to find what are the different ways the agentic system would be attacked, we realized that industry lacked a way to think about agentic system. Not only one attack, but the agentic system itself. Think about insurance agentic system. Like when you, in a big insurance, you have like somebody like does claims, right? And if you think about, there is right now it's a manual. A lot of things happen manually. If you were to create an agentic system around it, how do you think about what are the possible ways it could be attacked? So the industry doesn't have those kind of standards. So right now, the second big project we are leading is called SAFE, AUCA. It's like a SAFE agentic use case analysis, basically. Right? I think this might be very useful for you guys. Why I'm saying that this use case analysis is actually, if you go on the GitHub repo, like I had the QR, I'll put QR at the into. There is another, in that, go on the organization repo, and there is another project, use case analysis. So the beauty is this. I would say right now, because of AI, the skill of coding made coders commodity, right? I mean, being a great coder was unfair advantage, like, I don't know, 5 years ago, but now it's like everybody can be great coder, right? The alpha is not how to code, but it's like how fast you can connect with the right people. I think that's I think right now is the biggest alpha. And I think this might be one of your unique opportunity. What we are really doing is on this agentic use case analysis, we are bringing an industry expert. They will be like a director of engineering from this company, or like another like senior product manager from that company to write those use cases. And then right now we are also planning to get students involved too. You can directly work with those guys to write a specific use case, right? At that time now, what happens is you started building that network right away. So that's one of the biggest alpha you could get out of this project if you want to be part of it. And it's entirely open source. So there's always like that contribution you are kind of putting there. So I'm like, for the sake of time, I have 3 minutes, so I'm kind of like moving here. So think about this, like, so on this use case analysis, what is the value to the industry of this use case analysis is, think about we are doing a banking virtual assistant for account cohesion. That is one of the analysis you would write with some banking experts, right? Somebody who has worked on the banking domain for a long time. You will write with them together, right? And on that use case analysis, we have the use case ID, SAFE UC0011. What does that really mean is, think about another bank in another part of the world, or I don't know, somewhere. There is some architect in the bank, he has to create an agentic system. At that time, they will refer this as a guide, industry guide. So you are not just writing a use case, you are making an industry impact. I think that's the biggest value you could get out of it, is you can connect with some people in the banking industry, or like a fintech industry, or like any kind of different industry. We are right now bringing folks from like 30, 40 industry, like 40 big companies, right? So the guys from Atlassian, from Ford, from like Meta, and all those guys are like coming from the company saying, hey, we have this issue, we want to write a use case. That's general, right? At the time, what you are doing right away as a student here, you are writing with them. I think that is very unfair alpha, I would say, like you would get out of this project if you were to be part of it. So this actually use case analysis is one of the biggest initiatives we are pushing. And please, we would love to welcome you on that one. So there are different workflow families we are working to, a lot of workflow families. There will be 60s, 70s workflow family, and every workflow use case would have ID and those kind of things. So, okay, I have a minute, I guess. So I'll just stop here. And then if you guys have any question, feel free to ask. Sure. Oh yeah, definitely. There are few ways to do. One is you can, we have every Saturday a kind of a online event we do. Please join there too. Yeah, I'll send the link. I'll send the link. Yeah, and also you could like there is attack techniques. You can add new attack techniques. There is mitigation you can do, and also be part of use cases. So for example, few of the things I saw here, they could be one of the use cases. You can generalize that and have a use case. Because think about use case you are writing is a general pattern for the industry. Yeah, sure.
Thank you very much, Arjun. Let's give him a round of applause. And Arjun, I'm not sure, how long are you going to be sticking around for?
I'll be back. Give me like 30, 15 minutes, I'll be back here.
Okay, sure. Then will you be here at 5 o'clock? Yes. So students who are interested chatting with you, they can come to Starbucks and chat with you?
For sure.
Okay, perfect. Then people who are interested, please join Arjun at Starbucks at 5 p.m. All right, I think that this is pretty cool, and maybe we're gonna wrap it into some kind of semester project, industry-led project-ish. I'm not sure what's exact details. People who are leaving, thank you for coming. I know that classes are coming up. Yeah, but the main value here is, of course, getting in touch with the industry, because unfortunately you can be the best engineer ever, but if you don't have right connections, it might be tough to get in there. But now we're transitioning to our last but not least portion of this event, which is industry-led projects. All right, so again, to outline how we're going to do this, we're going to run this section for another 30 minutes for industry-led project, 30 minutes, and then after this, we're all going to go to Starbucks, grab a coffee. People who are leading the projects can talk with people who want to join projects. If you ever have any questions about industry projects, also, let's chat there. All right, so first company, Nuvoton. And the problem statement here is revolving around embedded AI computer vision for counting people in elevators. And I actually brought the hardware with me. So this is the hardware that you will be working with and putting your model on. This is Nuvoton Cortex M55 board with NPU for embedded AI applications. And I will talk about this a little more. So first of all, a little bit about the company, the Nuvoton. We call ourselves, I currently work there, we call ourselves the hidden giant of innovation, hidden champion. But actually, how many of you ever heard about Nuvoton? 1, 2, 3, 5 people, about 10% of audience. We're actually a top 3 global supplier for the chips. And if you have a computer, which I assume you do, most likely there is a Nuvoton chip in there. That's why we call ourselves hidden champions. We recently acquired Panasonic Semiconductor division. And also we have the full control over supply chain from designing chips to actually manufacturing them. NVIDIA, for example, doesn't do this. They design the chips, but then they ask TSMC to manufacture the chips. We do both. So the problem statement. Elevators are very sensitive to a number of people present in it. So if you have, for example, 4 people, but elevators thinks that there are 5 people, it might not get all the way up to the specific required height, and the doors will get jammed. And you will be surprised how often this happens. But hopefully no one ever got stuck in the elevator. Anyone ever got stuck in the elevator? Because of that, most likely. So how to solve this problem? Count how many people you have at the elevator. What makes it a little bit hard is that the environment is pretty constrained. So embedded environment has 10 megabytes of RAM, but you actually can run computer vision models, and I will power it up once we go to Starbucks. But hardware accelerated edge AI is the problem statement here. So another part of it is privacy and performance, part of the problem statement that all the processing has to be done here. You cannot send your data to the cloud because we want to avoid this as much as possible, especially with the computer vision tasks. So that's the board, that's the back, that's the front, and here it's running a pose detection model, again with 2 megabytes of RAM. It's able to do this. So the data for this project is not available. Data is something that you will need to find yourself, collect yourself, or find online. That's the part of the project statement. And then privacy first solution. Again, all the data has to be processed on device. There is a NPU chip, which makes it easier to process, but that's on the technical side. So deliverables, first deliverable, you would need to have the CVB running your model, placed somewhere up top, counting how many people are in the square, essentially. That's the first deliverable. The second deliverable is the model file itself. So here, most popular framework for this is TensorFlow. How many people heard about TensorFlow? Okay, how many people heard about TensorFlow Lite? Yeah, so that would be good if you did, because that's the environment that's used for this. And technical report is also part of the deliverable, maybe 5 to 10 pages, where essentially you describe the work you've done, the experiments you've ran, and what's the results. So the key skills, I would say this is a medium high level project because of the embedded system. How many of you have experience with Arduino ESP32 embedded systems? Yeah, so these are the people who are most likely will be a good fit for this project. That's a pretty hard part of it. And if you'd never had experience with C++ or C, that could be tough. But TensorFlow, embedded C, computer vision, data engineering, and hardware-aware deployment are key skills for this one. To apply, we're looking for 4 to 6 people here, 1 team lead, and another people who will be working on this thing. That's a form. It's going to be the same form for all 4 industry-led projects. And yeah, I think that's pretty much it that I have on this one. Is there any questions? Please. Because you need to know how many people, not the total weight of the cabin. It is a very specific part of it, which I'm not sure about, but I know that that's the part of it. You can't just use the weight sensor. You need to know how many people are there. Other questions? Nope? Okay. QR code as well as the link will be available on Discord too. So the second project, this one is more on data science, real world case. There is a business called PA-BAT. There is a company and they manufacture furniture. So they have a whole factory where they manufacture the furniture. And what they're trying to do, they're trying to take the data from the factory and to use it to optimize their business processes. So this one is for people who are leaning more towards the data science. So a little bit about the company. What they do is they do custom casework. They do custom kitchen cabinets, wardrobes, all kinds of things that you can make out of wood. And then they do the whole cycle. So there is a customer who says, I want the kitchen to look like this. And they say, okay, we're going to design the blueprints, we're going to design the things, we're going to manufacture them, ship them, install them. So the whole cycle of production. And then they track labor per work order, per work center. And I'm going to explain a little bit more about this later. But that's on the data that's available. So that's the business flow. Going left top, starting there. There is a customer, as I said. They want this specific piece of furniture. They then describe this, finalize what they want. Then the green one, there is a blueprint of the furniture produced, a PDF file which has all the dimensions and everything. And then this blueprint is sent to the work center. So for example, first we need to cut the wood, right? And then second, we need to assemble the wood together. So this is an oversimplified example, but essentially that's what it is. It takes X hour to cut the wood for this specific type of furniture, and then it takes Y hours to assemble it. And then the final piece is shipped to the customer. So this is how a sample blueprint looks like. It has dimensions, and that's as much as I know, to be honest. How many people here have experience reading blueprints? Okay, some people. That's going to be a great skill that will set you apart in this project. Anyway, so the problem statement is there is a piece of furniture, it has the dimensions. How do we predict or estimate how many hours it's going to take to cut it, how many hours it's going to take to assemble it, how many hours it's going to take to send it? That's high level of a project statement. And then second part of it, the stretch goal is to automate data entry from this into the database. But the main problem statement is to predict how many hours it's going to take to put together, manufacture a piece of furniture based on dimensions and type of it. So data, this is an interesting part because half of the data is available and half of the data is in the PDFs. So that's actually a very crucial part of this project, to take these PDFs and organize all this data into a spreadsheet so that you can feed it into a machine learning model. That's going to take time and effort, but that's a real-world skill that you will most likely need working in the real-world environment as a data scientist or machine learning engineer. And then that's the first part of the data, right? The dimensions of the furniture. And then the second part of it is how many hours it took. Historically, we have historical records, around 300 of those. How many hours it took for this specific piece with these dimensions to cut, to sand, to assemble. So that's the data. Deliverables. Primary objective here is to have a machine learning model that we can put in the dimensions and the type of a furniture piece, and it's going to say it takes 3 hours to cut, 2 hours to sand, 1 hour to assemble. That's done by a machine learning model. It can be linear regression, XGBoost, deep learning, maybe not, because it has to be explainable. And then the secondary objective is to automate this data mapping from the blueprints into the database or a CSV file. So key skills here, data entry, people who can read blueprints and transform this into the organized data set will very stand out. Then data engineering, because you will need to engineer this whole, first of all, data schema. Then you need to join multiple data sources. Then you will need most likely to clean it, make sure it's all good. Modeling, machine learning modeling. So in this case, most likely linear regression, XGBoost, DNN, maybe, but it's not too explainable. Then as a stretch goal, OCR, if you want to try to translate the blueprints into the CSV. And then communication with non-technical stakeholders. So that's actually, I think, one of the main skills that you can gain out of this project, because we're all here engineers, we're all here computer science, data science, AI students, and we think in these terms pretty easily. But then someone has a business and they have an Excel spreadsheet, and that's as much as they know about the data. So communicating with these people, because that's going to be your direct point of contact, is actually a very valuable skill that you will develop too. Here, the team is 6 to 8 people, and this QR code takes you to the same destination, same form. Yeah, any questions? All right, we're speed running that. SiMa.AI. Let me actually have some water because my throat is dry. How many of you heard about SiMa.AI? Well, obviously. Okay, SiMa.AI or SiMa.AI, I'm actually not sure how do I pronounce this. Hardware company. What's the difference between Nuvoton and SiMa.AI? They manufacture much more powerful chips. So for example, Nuvoton is if you compare it to a computer CPU, maybe capable to computer CPU you had 10 years ago. But it's smaller, much more energy efficient and all that. But SiMa.AI is a company that manufactures high-performance software, kind of like NVIDIA Jetson, I think, but in this direction. So it's not something you put in a server, it's something you put in actual edge device, such as a robot or Tesla. Yeah, to give you some idea. So SiMa.AI, they build high-performance, energy-efficient edge AI hardware and software. Applications are robotics, self-driving cars, rockets, any type of thing that you can imagine that needs AI on the premises. Why some applications need AI on the premises? Self-driving car, imagine you're driving on the highway, 65 miles an hour, and it's connected to the internet to run the autopilot, and the connection is lost. That's not good. So we want to do this on the edge. Important skill that's recently coming up with all this humanoid robotics and self-driving cars. But the problem statement is that they want to have some kind of application hub. So they have a platform. This is what you will be working with. Actually, a very expensive piece, $1,500. And they will give us 2 of those. And this first problem statement is to build a Model X application hub, which is kind of like NVIDIA. But the idea is that you need to design the end-to-end architecture of the application hub, maybe like an app store, something around these lines. It doesn't have to be that complicated, of course, but the general idea is that you can click a button, first application uploaded and running. You can click another button, second application uploaded and running. So here it says each team, but I think for this problem statement we have 1 team. But the idea is that you can develop 2 to 3 end-to-end AI application that run on device. So again, that's the hardware. The data, in this case, they specified these data sets. I'm personally not familiar with any of those, but that's what they mentioned. So no private data can be used. All the data has to be open source or collected by the students. And there is some starting code, so you're not going to be developing the thing from scratch. But the idea, again, is to build some kind of application marketplace, which is not as fancy as it sounds, but that's the idea. So deliverables, 2 to 3 working edge applications with configs and documentation. So any edge application, do you want to build a robot that recognizes the faces, or do you want to build something that drives around the room itself, or maybe you want to deploy a local LLM? Any can be here. This problem statement is pretty broad, to be honest, so I think students who are interested, they will be working directly with a representative to hash out the details. So this project is the medium level. The main skill, I think, here is reproducible system engineering. So you need to understand how the system works, how you train the model, how you deploy the model, how you evaluate the model. So it's less of a hands-on data task and more on the system engineering task. And then again, we have Edge AI, computer vision, real-time streaming pipelines, and performance benchmarking. Application takes you to the same exact form, and I'll take questions. Please. Sorry, I cannot hear you. But they will be, yes, you as a member, you can join either one industry-led project or one student-led project. You cannot join multiple projects. Correct. There is. You can apply to multiple. I would recommend applying to top 3 that you think you're the best fit and you're most passionate about, because we don't want to review millions of AI applications, please. But yeah, you will be selected for one project ultimately. I don't think there's going to be interview unless we have too many applicants, but there's going to be some kind of skill matching between whatever you submit in your application and whatever the project requires. All right, any other questions? Please. Well, these projects, they all have caps. So this one is 4 to 6 people. The previous one was 6 to 8 people. I think if you apply early and you have a skill set, because we're all students, right? no one here is shipping production AI systems. That's why we're students. That's why we're doing this thing, right? We're trying to learn. So the main idea is to learn. So if you have a good background, high chances you'll get in. And also considering that some people maybe went away to take a nap, I think if you apply here and be one of the first who does this, you have a pretty decent chance of getting in. Does this answer your question or not really? You're asking is what's happening if you don't get in the project that you wanted to be a part of? No, because there are caps on the projects. So if there are 20 people who apply to this project, only 6 will be selected to be a part of it. Can we take this question later on at the Starbucks at 15 minutes to keep the flow? Yeah, talk to me when we go there. All right, last project, physical edge AI autonomous robotics. So same company, SiMa.AI, and they're providing 2 pieces of hardware. So one is the application hub. It's been a long day. Second one is physical edge AI autonomous robotics. They want to build something that actually moves. So it can be a rover that drives around SJSU campus. It can be a robotics hand that operates, maybe handshakes people as it detects people getting in front of them. But sky's the limit. Again, they gave us very broad problem statements that allows us to get the people who are interested, and then these people can work out the details with actual company representatives. Right, so here they ask us to build a robot demo. I honestly have no experience building robotics applications at all, so a lot of these terms are alien for me. But again, the same hardware piece. And all the data here will be synthetic using ISAC simulation. So if you're not aware how all these Teslas and all these humanoid robots train, they don't actually go in the physical world and walk around or drive around. What they do is they generate synthetic data, which means that it's kind of like a game, and they learn how to play in this virtual environment first before they go in the real environment. So that would be the case with this project too. You would need to generate your own synthetic data. And then deliverables, it would be an ISAC sim world plus script and 5 scenarios in which your robot can perform. ROS2 package, I am not necessarily sure what it stands for, but if you have questions and you're interested, please apply and we'll try to address all the questions. And Modalix deployment, metrics report. Modalix is this hardware piece that you will be given. So does anyone know what's ROS2? Can you please tell us? Okay, thank you. That's very helpful. So there is a ROS2, which is a robotic operating system. So you will be developing applications for that specific system, I suppose. So yeah, that's as much as I can tell you here. But if you're interested in robotics, building your own robot, that's a really cool project. And again, team size here is 4 to 6 people. Feel free to apply. Summary. Nuvoton embedded AI. So this is for people who are interested in microcontrollers and very efficient compute. Computer vision for counting people in the elevators. Then the second one, PA-BAT, real-world manufacturing optimization. If you're looking into becoming a data scientist, you will gain a lot of good experience for this project. And then SiMa.AI, 2 projects. First one is on developing the Edge AI application hub. And then the second one is developing some kind of robotics physical AI. And I think that's it for me. I'm going to leave it here for a couple minutes, but officially that's over. Thank you very much for joining us today. And let's head to Starbucks to have a social.